Okay, here is another probability distribution chart which someone wants me to do something with. And if I add this all up, it doesn't quite add up to 1 because I put some little number in that one. Okay, if I just rounded that to 0.000, then add it up, it's 1. And there's a lot of rounding errors in it, which is why it's like that. And what this is imagine that you live in a certain neighborhood where you've got super strict homeowners association, and they say everyone's going to buy these fantastic bushes we saw on sale at Home Depot. You got to have 6 of them in front of your yard. And these are some sort of blooming bushes, and sometimes they bloom white, and sometimes they bloom pink, and sometimes they bloom red. Okay, and I just think that getting the white ones would be really nice. That's what I want in front of my house. That's what I'm considering to be a success. I'm hoping I plant 6 of these bushes. I'm hoping that I will get some of them with some white flowers on them. Okay, well, so in this case, white flower is success. I might get 0 of them. Okay, I might get 1. I might get 2. This is the number of bushes that'll be blooming white. Okay, all the way up through 6 bushes blooming white. Well, we know that's not going to happen. I mean, how can it be that all 6 of them are blooming white? That's why this number is so small. Okay, and why we're just kind of basically going to round it out. All right, but it could happen. It's just really, really rare. That's why there is a number there. You know there's actually a number. It's not 0, but it's kind of close to 0. And these numbers, where would these numbers come from? Well, if this really was a Home Depot problem, maybe Home Depot's had everybody in my neighborhood in there, and every single person in my neighborhood apparently called Home Depot back and told them just exactly how many of them bloomed white. So apparently Home Depot knows the probability of this happening. So that's just what we're going with for right now. The numbers come from Home Depot. Okay, anyway, so that's my chance of getting that number of white bushes in front of my house. Now, I'm just going to fill in this column. I know how to do it. Just multiply these two. So 0 times 0.178, 1 times 0.356, 2 times 0.297, 3 times 0.132, 4 times 0.033, 5 times 0.004, 0.02, and 6 times 0. We're just saying that's 0 because it's all rounding error anyway. Okay, and then I add these up. And apparently I got 1.498. That is the mean. We'll call it 1.5. That if I drive around my neighborhood, once all the bushes are blooming, if I drive all around my neighborhood and start saying, oh, there's a house with 3. Oh, and that one's got 1, 0. That one's got 2. Okay, I'm going to see a whole lot of 1s and 2s while I'm driving around because their chances are extra high. All right. But if I went all around my neighborhood and I wrote down every single house, I wrote down how many white bushes they had in front of their house, the average number of white bushes I'm going to see in front of anybody's house is 1.5. Now let's get the standard deviation again. I would take this same list of numbers. If I do it into one variable steps, it'll give me the standard deviation. So I'm going to take my 1.5. So 0 minus 1.5 squared, drag myself all the way back to this column, 0.178. Okay, so apparently that's 0.4005. 1 minus 1.5 squared times 0.356. And that was apparently 0.089. 2 minus 1.5 squared. This is about where I start to get really bored with the problem and I start getting distracted and being in this column. No, all the way back to 0.297. And so on, all the way down. This one I would get 0.074, 0.297, 0.206, 1.049. Okay, and this one I'm still going with there being a 0 here, so because I'm multiplying times this column, and there's a 0 in that column. All right, add all that up. Okay, that is 1.1155. That's the variance. Nobody cares about the variance. Take the square root. 1.1155. And the square root is 1.056. Okay, so if I drove around my neighborhood, wrote out all these numbers, stuck them into one variable stats, I would find out the mean is 1.5 and the standard deviation is 1.056. All right, so that's how to do those problems. That's just one more example. And then it comes on into this interpretation of the chart. So, I mean, you'd still have this on your paper if you did that part. But to answer these other questions, you really don't need this part. Okay, would it be usual to find 1 or 2? Well, I know I drove around the neighborhood and there was a whole bunch of 1s and 2s. Okay, so it probably would be. But usual has a meaning. It means you have to be within 2 standard deviations of the mean. And I just erased the part with the 2 standard deviations and the mean. I could have calculated what those numbers would be, but I didn't because I just erased it off of here. Okay, there's another way to do this. As long as you're not with the extreme ends of a bell curve. Okay, you're supposed to be within 2 standard deviations of the mean. The stuff outside of 2 standard deviations of the mean always adds up to 5%. It's weird. 2 standard deviation comes out to be exactly at the 5% mark. So 2.5% of your population will be over here in this tail, and 2.5% of your population are over there in that tail. And those are like the weirdo 5%. They're the unusual people. So if something comes out as less than 5% chance of happening, then you're unusual. And it exactly matches the mean plus and minus 2 standard deviations definition. Okay, the weirdo 5% rule comes out to be exactly the same rule. So I'm going to use the weirdo 5% rule. Probability of 1 or 2. Okay, probability of 1, 0.356. Probability of 2, 0.297, just using the addition rule here. And that comes out to be 0.534. Is that unusual? Well, that's like 53.4%. We're talking about the weirdo 5%. 0.534 is greater than 0.05, so usual. Okay, that is not unusual because it's bigger than 5%. That saves me having to use that plus and minus 2 standard deviations rule. I could just check the numbers this way, just see if it comes out to be bigger or less than 5%. Okay, 5 or 6. 0.004 plus, even if I use the unrounded one, 0.00424. Oh, that's way less than 5%. 5%. So this would be unusual. It kind of matches what we would have expected. If I'm driving around my neighborhood, I really don't think I'm going to see a whole bunch of houses with like 5 or 6 white bushes in front of them.